True or false? Is the first set contained in the second one? And the answer is yes, circles contained in, so this is true. Here we're being asked, is a spade an element of the four-member set? And the answer is yes, it is. So once again, we can put true. Work with sets at the beginning is often pretty easy, but there's lots of little tricks. This is a pretty tricky thing. Most people look at this and say, well, a quarter's inside there. There's a quarter, so yes, it must be true. But that's not quite right. It would be true if there were no set notation around this quarter, because a plain quarter is in the list. But this is asking, is this set? Not is this element, but is this set inside this list? And the answer is no. So this is false. One way to make it true, as I mentioned, would be to get rid of these two set braces. Then a quarter would be an element of this set. Another way to make it true would be to make this be a subset, or a proper subset symbol. One of these two. In this case, it would be true. Another way to make it true, which is past where we really need to be. But if you put this set notation around the quarter, then this set itself is an element inside this other set, and that would make it true. But as the problem stands, it's false, because there are no sets inside this second set. 17 says, tiger is not an element, which means it's not a member of the set of zebra, giraffe, and polar bear. And that's true. Tiger's not an element. So this is a true statement. In order to decide whether this is true or false, we might want to look at this statement. This is a proper subset, which means the first is contained in the second one, but not equal to the second one. In other words, there's some stuff missing here from the second one. And that's not true, because these in fact are equal. Yes, these are contained in here, but there's nothing missing here. These two are equal, and that's the inappropriate symbol. This would be the appropriate symbol, but we can't have that. So, this is a false statement. That means that this is true, because this says this first set is not a proper subset of the second set. So this is actually a true statement. In problem 27, of the choices, these are the two that are true. This says B is contained in A, and that is true. This says B is contained in A, but B does not equal A, and that's true. You know, this says contained in or equal to, kind of like less than or equal to, sort of. So these are the two that are true. We're going along minding our own business with some uninvolved problems, and then comes 39. There's an awful lot going on with problem 39. So it asks us to take this set and list all the subsets. So I listed the empty one, and then all four of them that have one element, and all six of them that have two elements, and all four of them that have three elements, and the one that has all four elements. And those add up to 16, which of course is 2 to the 4th power. Our book has told us that. I'd like you to notice that these numbers 1, 4, 6, 4, 1 occur in Pascal's triangle, a triangle that many of you probably have seen in earlier classes. Pascal's triangle, there those numbers are, and those numbers add up to 2 to the 4th power. So it's a lot of patterns going on here. In part B, it says which one of these is not a proper subset? Well, the set itself is not a proper subset, so that would be the answer to part B. Here's an example of a statement that's often true, but it's sometimes false, and therefore it's a false statement. All it takes, remember, is one counterexample to prove something's false. So all we need to complete our proof is two sets, A and B, where this statement doesn't work, where it's not true, and then we're done. And it could really be almost any of these, but I'm just going to put set A and set B are the same set, the set that contains 1 and 2. Now this is a true statement. A is a subset of B because each of these is contained in B. But this is a false statement. This says A is a proper subset of B, which means A's elements are contained in B, but the two sets are not equal. This one includes the possibility of equal, this one does not. And so this is a false statement because there are counterexamples, and the counterexamples often look like A and B being the same set.